Alright, in this video we're going to be discussing the third and fourth triangle congruence rules, which are angle side angle, which is ASA, and angle angle side, which is AAS. So the objective is, given two triangles, the learner will be able to use the angle side angle and angle angle sum theorems to determine whether or not the triangles are congruent. So again, ASA stands for angle side angle. And the definition is if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, they are congruent by angle side angle. And again, with angle side angle, the two angles have to include the included side. So again, that means the side has to come between. So let's take a peek at what that might look like. So I'll do two examples here. The first example, we'll just draw two triangles, and I'll give two angles here. This angle is marked with one arc, this angle is marked with two arcs, and we'll do these two here. Let's say that one has one, that one has two, that one has one, that one has two. So in order for it to be angle side angle, we have to have the included or the side that's in between both those angles. Okay, now let's say we have our hourglass looking triangles. And let's say that we have, it would appear as though we only have two bits of information here and two pieces of information here. However, we know that vertical angles are congruent. So that is angle side angle. Another example would be if I had two angles here, or an angle here congruent to that angle on that triangle, these angles, both right angles, or we can put two arcs there, we do know that the side in between these that they share is congruent because they're touching each other, the reflexive property. So we have angle, side, angle. So again, that's three examples of angle, side, angle. Our second rule is angle, angle, side. And basically that means I need two angles on one triangle with a side not included, with two angles on a second triangle with a side not included. So let's see what that looks like. Again, we need two angles on one triangle with a side that's not included, or not in between. And then we need two angles on the other triangle with a side that is not included, or again, not in between. So let's look what that looks like. So again, if I have two triangles here, I have angles here, and angles here, I would have to have, in order for it to be angle, angle, side, I would have to have a side that is not included with the two angles. If you trace around your triangle, you have angle, angle, side, angle, angle, side. Alright, let's look at another one. So what would appear again is if I'm only given two bits of information, I'm given this angle on this side, this angle on this side. However, we know vertical angles are congruent. So again, if I trace around my triangles, I have angle, angle, side, and the side doesn't come between. And again, angle, angle, side, the side does not come between. That's angle, angle, side. Let's take a look at the third example here. I know my triangles aren't perfect, but we'll go with it. So let's say we have this one would actually be angle, side, angle. Let's do a different one. Cross that out. So 2 here. So again, this one was angle, side, angle because I made the reflexive side the one in between the two angles. However, if I have angle, angle, side that they share, angle, angle, side that they share, this one will be angle, side, angle. This one will be angle, angle, side. Alright, so let's take a peek and see what pictures look like here. So the next rules ask us, are they congruent? You're going to either say yes or no. And then if so, which postulate or theorem can you use to prove the true triangle is congruent? So let's put all the markings we do know. We're given 2 angles here, 2 angles there. And I do know the reflexive side, the side they share, is congruent. So again, I have angle, side, angle. Angle, side, angle. Alright, number 2. I'm given side, side, and a side, side over here. However, I can't assume any angles are congruent. I don't have any vertical angles. They don't share any sides, so I can't say they're congruent. So that's only 2 pieces of information. That is no, they are not congruent. Number 3. They're giving us 2 pieces of information on that triangle, 2 pieces of information on that triangle. So it looks like right now I have an angle and a side here, and an angle and a side here. However, I do know the vertical angles are congruent. So the question is, I have 2 angles and a side here, 2 angles and a side here. The question is, does the side come between the 2 angles? And the answer is no. So we have angle, angle, side, angle, angle, side. Again, for it to be angle, side, angle, the side has to be between. That would look like if it was right here. Alright. The next one states, state what additional information is required in order to know that the triangles are congruent for the reason given. So, they want us to know what information would be needed to prove these triangles congruent by angle, side, angle. Well, I know for angle, side, angle, I need to have 2 angles with a side in between. What I do know is they're giving us these 2 angles right here. I do know, because the reflexive property, they share the side. The question is, what else will we need to know in order to prove it angle, side, angle? Well, I need angle, side, and I need the angle that would have the side between. So I put angle marks here at C. In the next example, they're asking us which markings I'd put on this to make it congruent by angle, angle, side. So again, they're giving us these angles here at L and O are congruent. Vertical angles N at N are congruent. There's a couple different ways you can look at this. For angle, angle, side, I want the side that is not between the angles. So I can not choose this side right here, and I can not choose this side right here. So I either need to choose the 2 sides that are next to the double angle markings, or the 2 sides that are next to the single angle markings. Both would work. So if I put markings here, I would have angle, angle, side, angle, angle, side. Likewise, I'm just going to redraw it here. If I were given these angle measures here, are congruent, now what I could do is, instead of saying these sides are congruent, I could say that these sides are congruent. Because then that would be angle, angle, side again, angle, angle, side. It doesn't matter. You just need to have 2 angles with a side that is not in between. And for our last example, I want to prove again angle, angle, side. What I do know is that this angle they're telling us W is congruent to W on the 2 triangles. I do know that WY is congruent to WY because of the reflexive property, but I need to have angle, angle, side without the side between. So I do not want to put my marking here at Y because that would be angle, side, angle. Instead, we're going to say that X is congruent to Z. Again, I have angle, angle, side, angle, angle, side.